Hello everybody, and once again welcome to Pankaj Sir's Echelon Tutorials. In this today's session we are going to deal with chemistry, IGCSE chemistry, and you can see on the screen we are going to solve this paper in chemistry. This is paper 6, which is alternative to practical, and the paper code is 0620 and the paper number is 62. Okay, paper 6 version 2, and this is May-June 2020 paper. Okay, and the duration for this paper is 1 hour. The marks allotted for this paper is 40. Okay, so let us get started with this paper. Here we see question number 1. Question number 1 says that hot copper to oxide, okay, reacts with hydrogen. The products are copper and steel. So let me write the reaction for this. Okay, so reaction can be written as copper to oxide is CuO, and it is reacting with hydrogen, so plus S2 should give us copper plus H2O. Right, so this is a balanced equation for this particular experiment. So the products are copper and steel. The apparatus used to react copper to oxide with hydrogen is shown over here, and this is the arrangement you can see over here. Let us see what is question number A. It says that draw an arrow to show that draw an arrow on the diagram to show where the apparatus should be heated. So obviously, because the copper oxide is kept in this tube over here, so you have to heat this copper oxide at this particular point. So this is the answer. B is during the reaction, the color of the copper to oxide changes. State the color change. Now it is well known that copper oxide normally is black in color, and in this particular experiment, copper oxide is going to change into copper, and you know that copper is brown in color. So in this particular, the color change will be from black to brown. Black to brown. Next question is identify the colorless liquid collected. So this is the liquid collected over here, and this colorless liquid has to be nothing but water, H2O. So I'll write here water as the answer. Now explain why the U-tube is kept in the ice. Okay, so when the reaction takes place, okay, you can see that H2O is getting collected over here, but it is in the form of steam. Okay, so the steam has to be condensed, it has to be cooled so that it gets condensed and it gets converted into water. So the answer will be the steam produced in this experiment has to be or must be cooled cooled down so that it condenses to water. Fine. Next question is question number 1, subquestion E. Here he says that large amount of unreacted hydrogen should not be allowed to escape into the laboratory, and state why. So obviously hydrogen, the unreacted hydrogen being inflammable or being flammable may explode. Okay, and that's the reason it is not allowed to escape into the laboratory. Next question is complete the diagram to show how the unreacted hydrogen can be collected and its volume be measured. Okay, label any apparatus that you can draw and show. Okay, so I'll do one thing. I'll draw a throw, and this throw contains water, right? So contains water. And there's an arrangement of a crucible over here. From here, I'll take a rubber tube which is passing through this crucible, okay? And on the top of this crucible, I am going to place now here I have to be. I'll have to place a inverted measuring cylinder, right? Now this is my inverted measuring cylinder. So the bubbles of hydrogen, right, will be, this is all water, right? It's all water. So the bubbles of hydrogen can be seen arising from this tube, and by the downward displacement of the water, the hydrogen will be getting collected over here, right? It's hydrogen gas. Fine. So this is that arrangement, and because we want to measure this volume, so this cylinder has to be calibrated. Okay, so it will be like having markings on it, right? It will be calibrated. It will be calibrated. Calibrated measuring cylinder. Measuring cylinder, right? Fine. That was question number E of question 2. Let us move on to the next question. Now here, a student investigated the temperature change when magnesium ribbon reacts with the dilute sulfuric acid, and 5 experiments were done. So experiment number 1 is described over here in detail. Then experiment number 2, 3, 4, and 5 is also given over here. So basically, this is a reaction taking place between magnesium ribbon, that is magnesium Mg, and your sulfuric acid, that is H2SO4, dilute sulfuric acid. And this reaction will give you magnesium sulfate and hydrogen gas, right? The reaction, basically. Now let us see what the experiment is saying. Using a measuring cylinder, 20 centimeter cube of dilute sulfuric acid was poured into a boiling tube. A thermometer was used to measure the initial temperature of the acid, and 1 centimeter length of magnesium ribbon was added to this acid in the boiling tube. The acid and the magnesium ribbon in the boiling tube were stirred continuously using a thermometer. The highest temperature reached by the mixture was measured. The boiling tube was rinsed out with distilled water. And in the remaining experiments, that is experiment number 2, 3, 4, and 5, all the arrangement was same. Only thing is the magnesium ribbon, the length of the magnesium ribbon were taken as 2 centimeter, 3 centimeter, 5 centimeter, and 6 centimeter respectively. So that was the experiment, and let us answer these questions for this. Okay. So the question says that use the information in the description of the experiment and the thermometer readings of the thermometer diagrams to complete the table. Okay, so this table you have to fill up. Length of the magnesium ribbon. Now these are the 5 experiments, 1, 2, 3, 4, 5. Okay, so length of the magnesium ribbon for the first case is 1 centimeter. Then for the second it is 2 centimeter. For third experiment it was 3. For the fourth experiment it was 5 centimeter, and for the fifth experiment it is 6 centimeter, right? So these are your readings for the length of the magnesium ribbon. Then the initial temperature of the acid, you can see that everywhere the temperature is 20, 21, 22, 23. Yeah, so 23 degrees centigrade. Here also I can see it is 23. The initial temperature for all the 5 experiments he has kept same. So I'll write everywhere 23 degrees centigrade. Okay, and you can see here it is 23 only everywhere. Okay, then the highest temperature reached by the thermometer. Now these are the thermometer readings. Now going by these readings, this has to be around 24 degrees centigrade. And this is, I think, 26 degrees centigrade. This is around 29 degrees centigrade. This reading, it looks to me like 36 degrees centigrade. And this is 40 degrees centigrade. Okay. So these are the highest temperature recorded, and I can take it from, I have taken from this diagrams of the thermometer reading. Now last column is temperature increase. So temperature increases from 23 to 24, that is 1 degree centigrade. For 23 to 26, it is 3 degrees centigrade. Here it is 23 to 29, that is 6 degrees centigrade. And here the rise in temperature is 23 to 36, works out to 13 degrees centigrade. And here it is 17 degrees centigrade. Fine. Okay. So the table has been filled up completely. Now let us see what is the next question. In which experiment 1, 2, 3, 4 or 5 was the temperature increase the largest? Now from the table you can see that the 17 degrees centigrade is the increase in temperature for experiment number 5, and that is the largest increase in temperature. So my answer for this question has to be in experiment number 5. Okay. Okay. Next question is, next question says that add a suitable scale to the y-axis and plot the results from the experiment 1 to 5 on the grid and draw a smooth line graph, making sure that your line passes through 0, 0. Okay. So you can see the y-axis is temperature increase in degrees centigrade, and the x-axis is the length of the magnesium ribbon. On the x-axis, already they have calibrated. Okay, the scale is there. So 1, 2, 3, 4, 5, and 6 centimeter. This is the length of the magnesium ribbon. This we will have to mark the scale. Okay, so it is starting from 0. So let us see what was the temperature increase range. So temperature increase range is from 1 to 17 degrees centigrade. So very nicely what I will do is, I will take some, let me take 1, 2, 3, 4, 5. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So somewhere, 1 second. Huh? This is 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Somewhere over here, okay, this I will take as 5 degrees centigrade rise in temperature. And then next 10 boxes, that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here I will take 10 degrees centigrade rise in temperature. Then again 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This I will take as 15 degrees centigrade. And again 1, 2, 3, 4, this will be 20 degrees centigrade. Okay. So you can see that on the y-axis, I have taken the points 5, 10, 15, and 20. Okay. Now explain why the graph must pass through 0, 0. Now obviously the graph must pass through 0, 0 because when the ribbon length is 0, no reaction takes place. No reaction takes place, and no increase in temperature. No increase in temperature. Okay, and this is the reason for on the x-axis you will have to take 0, and the y-axis also you will have to take 0, 0. So it will be 0, 0. The coordinate for the starting point will be 0, 0. Now let us do one thing. Next question is from your graph. Okay, so we'll have to first draw the graph also. Okay, on the grid. Okay, this question is not complete. Draw a smooth line graph. So you'll have to draw the graph. So for drawing the graph, you'll have to take the corresponding points. So points will be like 1, 1, and 2, 3, 3, 6, 5, 13, and 6, 17. Okay, these are the plots. These are the points that you have to plot. So 1, 1 will be, this is 1, so this will be 1, 1. Okay, this is 1, 1, and 2 is 2 is 3 degrees centigrade. Okay. So for magnesium length, magnesium ribbon length 2, this will be 3. So it will be 1, 2, and 3 somewhere over here. Okay. Then for 3, it is 6. So this is 5. This will be somewhere over here. It should be 6. Okay. And for 4, we don't have any reading, right? No. For 5, it is 13. For 5, we have to go to 13. So this is 10, right? And from 10, let me go to 11, 12, and 13 somewhere over here. Okay. And for 6, it is 17. So corresponding to 6, it is 17. So this is 15, right? And this is 16, and this is 17, right? Yeah. So let me join the points. So I'll have to join from 0, 0, right? So my graph should be running this way. Okay. And it should pass through all these points, right? So this is my graph. These are the points. Fine. So this is basically the smooth graph that I get. Now he's asking you to, after drawing the graph, okay, now he's asking you to find the temperature increase in experiment number 1, that is when the length of the magnesium is 4 centimeter. So corresponding to 4 centimeter, so from 4 centimeter, okay, I'll have to see what is the reading over here. Okay, so here the reading is somewhere. Okay. So this is somewhere near 8 and 9, between 8 and 9. Okay, so let me take 9. Okay, so the answer will be, I'll write here 8 to 9 degrees centigrade. Okay, 8 to 9 degrees centigrade. Fine. Somewhere between 8 and 9, right? Next question is, why would carrying out the experiment in a polystyrene cup rather than a boiling tube improve the accuracy of the result? Now, polystyrene is a good insulator, okay, compared to the boiling tube which is made of glass. So polystyrene is a good insulator, and this will prevent any heat loss to the surrounding. Okay. So that is why the accuracy will be more. Next question is, sketch on the grid the graph you would expect if the experiment was repeated using a polystyrene cup. So if polystyrene cup was used, then maybe this particular graph for every length, the temperature would have been slightly higher for every point. Okay. So for every length on the x-axis, this temperature would have been a little higher. Okay. So my graph would have been something like this. Okay. Fine. Now next question is, the volume of the dilute sulfuric acid could be measured with a 20 centimeter cube pipette. State one advantage of using pipette rather than the measuring cylinder. Now, pipette will give you accurate reading of the volume. Okay, so pipette, P-I-P-E-T-T-E, pipette is more accurate to use. Okay, because in pipette, the 20 centimeter cube can be measured very accurately rather than the measuring cylinder. And what is the disadvantage of using a pipette? So while using the pipette, you have to be a little careful. So the disadvantage will be using a pipette may consume more time. Consume more time. So the process will become a bit lengthy. Okay. Next question is question number 3. Now he talks about two solids, solid L and solid M, and they are analyzed. Solid L is chromium 3 chloride. Okay, so chromium 3 chloride, you know, is CrCl3. Okay, chromium 3 chloride, and okay, let me not write the formula. I'm not sure about it. So chromium chloride is the solid L, and tests which is done on solid L are given over here. Complete the expected observation. So solid L was dissolved in distilled water to produce a solution of that chromium chloride, and this solution was divided into 4 portions in 3 test tubes in the boiling tube. Okay. To the first portion of this solution L, that is chromium chloride solution in the boiling tube, about 1 centimeter depth of dilute hydrochloric acid was added. So what they did is they added some dilute hydrochloric acid, and the observation, and then what they did is a strip of filter paper was taken, dipped in acidified potassium manganate, and it was held near the mouth of the boiling tube. Now what should be the observation? Now basically this particular test, that is adding of hydrochloric acid, dilute HCl, and then testing with, so whenever you add dilute hydrochloric acid, okay, now, and when you test with the potassium permanganate, acidified potassium manganate filter paper, okay, you will be seeing that if now this is a chromium chloride, this L, the substance L is chromium chloride. Okay, so for chromium chloride, this is a test for sulfide. If I am not mistaken, this is a test for sulfide. Okay, so you know that in this L, in this substance L, you don't have sulfide, you have in fact chloride. So observation will be negative. So there will be no change. So observation will be no change, because this test is supposed to be for sulfide. Okay, and our substance is not sulfide, but it is chromium chloride. Now B part of the question says that in the second portion of this L, aqueous solution of chromium chloride, sodium hydroxide was added. So now we are adding sodium hydroxide, and it was added in excess, and further changes were seen. So now chromium chloride, okay, when you add sodium hydroxide to it, okay, green PPT will be formed, and this green PPT is formed, and when excess of sodium hydroxide is added, okay, excess of NaOH is added, then what happens is this green PPT gets dissolved. So you get green solution. Okay. So this is the observation for this part. Now next question is in the same substance L, okay, which is chromium chloride solution. Now suppose you add aqueous ammonia. Now aqueous ammonia is nothing but ammonia solution. Okay, so when ammonia solution is added, what happens? So ammonia solution is added, and when it is added in excess, what happens? Okay, so here this is a test for here you will see that again green PPT will be formed. is formed because ammonia is also basic in nature, but it will not get dissolved. Okay, the bud will not